Thank you. Do you hear me well, or I should speak a little bit? Okay. Okay. Well, as announced, yes, my name is Silvia. I'm working in an Estonian-based company called Clarified Security, and my daily job is to work as a web application pen tester. And well, I'm also one of the co-founders of TallinnSec, so we finally managed to start having the IT security meetups in Tallinn as well, which focus on the technical aspect of IT security. And well, 2018 happens to be my very first year of ever giving conference talks, so I'm still pretty new to that one. And as part of the project I'm presenting you today, I managed to get my very first CVEs. So call me a newbie if you want, but yeah. So those of you who have never heard what Electron framework is, it is basically a framework which enables you to build desktop applications, but to do so for multiple platforms. And if it happens that HTML, JavaScript, and CSS are your friends or something you're familiar with, then you should have a pretty easy time developing your own desktop applications as well. Electron actually came around in 2013, and it was developed by the GitHub team, as mentioned. And later, it got renamed to what we know of today as Electron in 2015. What actually got my attention, why did I start looking into this topic in the first place, was I started noticing people posting all these news snippets and tweets. And all these tweets, they were about having code execution on a desktop, but it was happening now via JavaScript, and they made it look so simple. So one of the tweets, actually, what really got my eye, and it was so spot on, was this one. So can you imagine a person coming up with an idea? Let's reinvent the whole essence. What is a desktop application? Let's make it easier for the web developers, of course, but then let's make it in such a way that it would also transfer the web vulnerabilities onto the desktop environment, but allow these to actually get super nasty. So nevertheless, having remote code execution really easily on a desktop, these big names followed. So they adopted the framework, and soon after, a literally huge list of open source projects followed. And Electron also advertises these projects on its official site. So coming from 2015 with a little bit over 100,000 downloads, then now in 2018, the number of downloads is already more than 4.3 million. So the user base has actually grown immensely. So that's more than a big reason to actually look into it, right? So when I'm talking about the framework, I'm actually talking about the three core components, which is the Node.js, then the libchromium content module, which it's used in order to render a page with a specific content we want to display to the users, and then the V8 JavaScript engine is what ties it all together. So the Node and the Chromium actually share a single instance of it. Similarly to Chromium, Electron also uses a multi-process architecture. So we have one main process and then one or multiples of render processes. And each of the processes' memory and their resources, they're running concurrently. And as a safety mechanism, if one of the processes actually has a failure, then here, because of the isolation between the processes, the rest of the application would still manage to survive it. So to give you an insight what a super simplistic Electron application would look like before we get into the main topic, we can take a look at these three files. So the main.js, index.html, and the package.json file. So package.json obviously has all the versioning, dependencies, but it also has the application's entry point, which in our case is the main.js file, and this is what gets executed within the main process. And later on, within the main process, is also the place where you specify. The content we want to display to the user should come from index.html file in our example, but it could also be simply remote URL. So if you look inside the main.js file, this should be all that you need for a really simple application. But you see I've highlighted there the browser window. So Electron actually comes with a set of framework-specific APIs which you can use. And these are divided between the main and the renderer process. And a couple of them you can also use from both. But browser window is one of those that you should be using from the main process, as the name says, to create the new browser window, obviously. And it comes with a set of options, so we can have the width and height, maybe. And later on, we specify that in this example, the content should come from the index.html file, like so. So what happens in an Electron application when you create the new window? Besides the width and height that was on the previous slide, it actually has a really, really interesting set of web preference options. So we're going to focus here on that. The web preference options actually allow you to control a variety of things, whether you want your users to be able to have access to developer tools. So this is something that could help you either to find the bugs, or maybe it could help me to find a vulnerability in your application, as we're dealing with JavaScript. It is also possible to sandbox the renderer processes. But remember that Electron, as an application, it should give you a desktop-like experience. So what happens if you decide to sandbox the renderer processes is that automatically the Node.js engine, what gives you that desktop experience, is lost as the engine is disabled. And it's also possible to control the usage of JavaScript, or by setting the web security option to true or false, you could either switch on or off the same origin policy. So it's pretty easy to control it. As part of this project, node integration was what I was taking a particular interest in, because that was actually the main thing in Electron, what makes a difference if it's simply a desktop application, or you could as well go and see it in your browsers. But that was sort of what was bringing it all together, because that was allowing the interaction with the underlying operating system. So to demonstrate the node integration, or what it actually looks like if you encounter it turned on or off, we can have a really simple script to demonstrate that. So I simply require the OS module, because I want to display you some platform and home directory information. If I place the script into a context where node integration has been set to true, then I get exactly what I asked for. So all the information is there. However, placing it inside the browser window where node integration has been set to false, then it's a blank space there. And if you look into the console, you have a reference error as the engine is now turned off. So this example is an obvious case. We wanted it to happen. We knew that it would happen. But what if you take the same script, you do not load it from the index.html file, but instead you have an application, let's say a form, you submit something and it's displayed back to you. So perfect case scenario to have a cross-site scripting vulnerability. Let's paste the same thing here, but as a user input. So the code is rendered as part of the program's code. We have a cross-site scripting vulnerability, but how is this one a different case than what's happening in a web application? So the difference here lies in the fact that the cross-site scripting vulnerability occurred in a context where we had node integration set to true. So you were able to ask questions about the underlying system on which the application was working upon. So that's allowed a simple cross-site scripting vulnerability evolve into code execution. And this one happened a really, really simplistic way, didn't it? So not even that, but if you actually examine, if you actually examine how Electron applications are launched by default, so if we do not touch the web preference options whatsoever, you would see that renderer processes always are launched without any protective layer of sandbox, and the node integration by default is always set to true. So the framework is built in a manner that the application would work out of the box. But maybe in this case, this happens to be a little bit too much of a freedom? Yeah? OK. So that actually allowed me to come to two assumptions. So if something already works out of the box, what are the odds that a person would actually go and risk it? Maybe I shouldn't touch it, maybe it's gonna fail. Or what are the options that, if it's already working, why should I bother touching it anyway? So the first assumption was that node integration would most likely be left untouched, which is the true. And assumption two, so when I'm dealing with pen tests on web applications, then cross-site scripting is something so common. And Electron itself, as a new framework, now has a bunch of web developers coming over to this desktop environment. So if they make the mistakes related to cross-site scripting on the web, then maybe they're coming to the environment of a desktop, and they think, how on earth can a web vulnerability actually occur on a desktop? Maybe they feel a little bit more relaxed, like I shouldn't really be paying attention to it. So based on these two assumptions, it only took 3 steps to conclude this whole project. So I went ahead, picked 30 applications in this case. I tried to see what kind of web preference options they have in their source code. And well, in Electron's case, it's super simple. They have their own mechanisms how to pack the application, but simple strings, and you have the whole source code right there. So not a really good way if you have commercialized products. And then the third step, simply go and find a cross-site scripting vulnerability. So it shouldn't be too hard, right? So in case all these 3 things were there, I would instantly end up with a code execution. I also wanted to gather some initial information on the applications I was looking at, because I had never really dealt with Electron applications. So I was looking into what kind of APIs they were using, what was the remote content, and how they were including it, as well as the options I was going to use for the long run. So what I found out was Electron has 59 framework-specific APIs, from which only 16 were used in these 30 applications, so that wasn't too much. So not a lot of different kind of functionality there in that sense. And one of the things that got my eye was the remote module, as this is a module which basically enables you to have access to the main process modules, but to do so from the renderer process. So this allowed me to assume that the most valuable functionality for the developers was within the main process modules. When it came to remote content, the 4 advised ways that I could find in the documentation, they weren't really used. And instead, all the remote content was preferably opened within the user's default browsers by the usage of shell open external method. And surprisingly, it was still served over HTTP for some reason. So I don't know what's the deal with that, but that was certainly interesting for me. And you remember my assumption. If something works out of the box, why to go and touch it? Maybe I'm going to break it. So this assumption actually proved to be true, as in 52 browser windows which were created in those 30 applications, in 46 cases, it was literally by the book. So nobody had really gone there, put it to false or true or anything. It wasn't there. And in 5 cases, it was turned on, which was already a default value, as it wouldn't change anything. And in 6 cases, developers went ahead and turned it off because they didn't maybe need it. So this basically gave me 46 good chances to go and hunt for cross-site scripting vulnerabilities, which immediately, as I found them, would be turned into code execution. So I ended up with 10 applications that were by the book, all 3 steps. And 9 out of those 10 was where I managed to find a code execution flaw within 5 minutes. And if you see the description of these applications, they are really into markdown editors, node-keeping applications, or anything to do with time management or task management. So I wouldn't really go into using one from that list. And how did it actually all look like? So Leah notes, was an application which was encouraging you to share and cooperate with your friends. And they also had a web application version of the desktop application. And you could synchronize that data from the web to be displayed on the desktop. So if you have a bunch of nice friends creating you some content, and then you go ahead and synchronize it on the desktop, then what wasn't vulnerable on the web then turns to be a code execution on your machine. As simple as that. So all it took was this little script. Could probably make it shorter, but yeah. So you could create a child process and then simply create the connection back to the attacker-controlled machine, and you could do whatever you want. So in this example, I'm simply stealing your etc password file. And just to show that the code actually got executed, so alert 1 is there, and on the background, while you stare at the number 1, I already had everything from your machine. So when it came about to taste the fruits of my labor, I actually found out that the developers weren't really aware of having web vulnerabilities on the desktop. So I wasn't really welcomed, and the ticket itself was literally closed before I could even send in the report. So took note on that and continued. I'm not going to give up yet. And then came the Shibo Markdown editor. So here the attack vector was a bit different, as the attacker had to trick the victim into opening that Markdown file right there. But good for the users, as a lot of these applications actually come with this welcome page where they explain the Markdown syntax and everything. So it actually takes only for you to open the application, then the welcome page would already be there, and on the background, done. So, yeah. Sorry, yeah, I have a video about that. So on the left side, you can see the victim's machine. On the right side, you can see the attacker's machine. The attacker simply starts listening on port 337. The victim will go ahead, open the Shibo Markdown application with a nice birthday note that I just sent. And he's done. So if this is literally not the easiest code execution you have ever seen, then I don't really know what is. So then, thank you. Then when it came about Mo editor, so it was all like nice looking application. And as you can see, this was with a public disclosure, so it's not fixed. It wasn't still welcomed. And why I bring this up here was that I contacted the original owner of this project. And now you can laugh. So the original owner of this project actually gave this project away to another guy. But the funny thing with desktop applications is once it's online, it stays there, right? Now, after sharing the application, there was 2 vulnerable versions with code execution of the same application. The previous owner didn't bother or want to fix it, and the new owner just raised this help wanted flag, so he didn't know how to fix it. So that was basically an impossible situation for me, as I reported something that actually matters. People were using this application a lot, but from both projects you could see that it wasn't going to be fixed. So I asked the question of, seriously. But then came the time of a little bit better odds, and I started to look into the Joplin application. So by then, I had actually managed to have like a set of information to provide to the developers so they would actually believe what I'm saying. And this one, I actually got a response in 36 minutes, and the fix was there by the next day. And just the other day in Twitter, I saw one of the security guys actually tweeting that he's going to use it. So good luck. But yeah, that was all it took to fix the problem. So bring something funny, and they're going to do it. But as a quick takeaway, I would be advising you to be cautious when using Electron applications, as in most cases, the desktop experience involves node integration to be set to true, but if they do not deal with user input in a correct manner, then it can be turned into something really, really awful quickly. But at the same time, from my perspective, or maybe from yours, this is still a really, really amazing playing field if you want to have good findings. And Electron also came out with their 2.0 version, where they have actually now started to establish their security checklist with good examples and solutions. And if you manage your applications from the console, they actually give you the warnings and recommendations, or if something is outdated. And some ideas to finish off this talk. So what if we have this situation? There is a code execution vulnerability, and it's there because of XSS. So I would suggest for the framework to have this kind of ability to control whether or not the attacker can actually go and require some extra modules. Because if he cannot, then he's restricted to what's already required within those applications, and he can't do more. And the other thing is, the assumption number one that I had, if something works out of the box, then probably node integration would be left untouched. But if you go and turn it false, okay, the application might not work on your first try, but you're actually going to find out that there is this option that exists there. And if you simply set it to true, everything's going to work because you needed it for that browser window. And if you don't change it, fine, it's a static page. You didn't actually need it. So that's what I'm going to finish it, and thank you.
So thank you very much. Do we have any questions? Yes.
Great presentation. Thank you very much. I really enjoyed it. Have you had a chance to explore how you can do something on a Windows backend system? Because modern Windows desktops are pretty nailed down in terms of things that they allow for processes to run. So do you think it would be possible to, I don't know, download Mimikatz or something and run something really interesting on a backend Windows system?
Well, Electron itself is for multiple platforms, right? So you can also use it in application on your Windows platform. And actually, if you look into the last CVEs that have come out about the Electron framework, which mostly have been bypasses to the case where node integration has been disabled to turn it back on. So in that sense, I have not personally looked into it, but it is possible.
As a web pentester, do you believe in web application firewall? And could the same technique might be applied on Electron apps, some kind of layer, similar like web application firewall?
Well, I would say, if you have to use a firewall, then you're already scared about something. So I would say the first thing that you should do, from my perspective, is to make sure that your applications are behaving they're supposed to, and there's maybe close to zero vulnerabilities there, which is almost not possible. But if you could do that, I would prefer you to go and actually take care of your application first before applying the layer of firewall for that. But probably Electron could take use of that, as the mistakes that I've seen in Electron applications right now, they happen more often because people feel too safe there. Yeah.
Okay, we have another question at the back.
Hi, thank you for presentation. I've enjoyed your machine on Hack the Box. Thank you for it.
Okay.
Yeah, you know what about I'm talking, yes? Okay, I would like to ask about this particular presentation. What are the key points that let you, when you are enumerating an application, that it is run by Electron framework? It's some specific JavaScript code.
You mean to identify with it whether it's an Electron application or not?
During enumeration of any...
For this particular project, I did not perform any enumeration. But what I did, like to identify whether it is an Electron application, but what I did was, well, there is a list that Electron advertises by themselves on their site, but as well, you could go to the GitHub and you could literally sort by the tags to find all of the Electron applications. So that was what I did here. Mm-hmm. It was literally the fastest method to get to the point where I wanted to get.
Mm-hmm.
Yeah.
And if you imagine working with some, I don't know, unknown for you application, you are inspecting it, enumerating, how it can possible to be identified as run as Electron?
Well, you could enumerate the modules, for example, because there's all like the modules they can use, they're framework specific. Yeah.
Okay, thank you.
Hello, this is yes.
Hi.
So yeah, I guess this is kind of related to the previous question. So did you build some scripts or automated tools to go through the code? And do you think this could maybe be used to develop kind of checker or lint for Electron apps to identify like kind of security anti-patterns?
This one, I'm not personally working on that, but I have some information that it's soon gonna come up. Okay. Yeah. So a little bit patience and it's going to be right there.
Oh, excellent.
Yeah.
Okay, thank you very much. And congratulations on your first CVEs.
Thank you. Oh, thank you.